All right, today we are going to do the percent of water in copper 2 sulfate pentahydrate lab. So the first thing we have to do is clean our crucible. So I already rinsed it out, and we want to heat it over the burner for about 2 minutes just to drive off any impurities that may be already contained from previous labs. There we go. So we'll let that heat for about 2 minutes just to burn everything off. All right, so the 2 minutes is over. So I just want to take this and sit it down on this cooling pad. I want it to cool all the way down to room temperature before I put it on the scale so that I don't have any mass errors. So we'll come back when that's cool. All right, so our crucible cooled all the way down to room temperature, and I put it on the scale to get its empty mass. So this is the mass of the empty crucible. It's a little bit of fluctuation, but 32.68 is the mass for the empty crucible. All right, so I added our copper 2 sulfate pentahydrate to the crucible, and it looks like we're getting around 4.15 grams of sample. It's fluctuating a little bit, but 4.15 grams of sample's good. Now, notice the color before we heat it. So the color of the copper 2 sulfate pentahydrate is a nice light blue color. That's very common for copper compounds. So if you have a blue solid, it probably contains copper. So now we're going to take this over to the burner and heat it for the next 12 minutes. And we are going to heat it vented for 12 minutes. Now with this lab, this is a little more finicky because it's really easy to burn your sample, and we want to drive off just the water. So I'm going to use a lower heat, and I'm going to just sit here and I'm going to move the burner around the bottom of the crucible and heat it for 12 minutes to drive off all that water. All right, so we just finished our first heating step, and you notice that our sample is a different color, so it no longer has that blue color. That is because all of the water in the copper 2 sulfate pentahydrate was just driven off. So we're going to let this cool. It'll probably take about 10 minutes to cool. And once it's cooled down to room temperature, we'll put it on the scale and see what the mass is. All right, so our sample cooled all the way down to room temperature, and I put it back on the scale. And we're seeing we're getting a mass of 35.34. Now, it's a little bit of fluctuation because there is a draft. So 35.34 is the mass of the crucible and the anhydrous salt. Anhydrous means it's dry. So after I've gotten rid of all the water, I have the dry salt inside my crucible. All right, so now that we have the mass, I'm going to put it back on the burner for another 5 minutes because I want to make sure that I've driven off all the water. So we are trying to achieve a constant mass. So once this heating's done, we're going to put it back on the scale, and if it's the same mass that we had the first time, we know we've driven off all the water in our sample. So again, another low heat, because I don't want to overheat my sample. It's really easy to burn it. If you burn your sample, then you might pull some other components of air into the crucible. So that would raise our mass a little bit. So we don't want that to happen. So again, another gentle heating. I'm going to be moving the burner around for 5 minutes. So our 5-minute heating has just concluded. So I want to take my sample and let it cool on this cooling pad until it's room temperature again. So once it's cool, we'll go put it back on the scale. All right, so now that our crucible is cooled all the way down to room temperature, I put it back on the scale, and we see we're getting a little bit lower of a mass. We're getting 35.32. So that's only a little bit off of what we had before, so it's within 0.1 grams. So I'm going to say that we've driven off all the water in our sample. So this is our final result. So you'll want to record this down as our final mass, and you're going to want to use 35.33 in your calculations. So show all your work, answer any questions in complete sentences, and that's it for the lab.